receives. That means whatever is intelligent only this will be at the antenna, and I'm listing them here. Some of you were writing here 3 kilohertz. No, 3 kilohertz will be demodulated and given to the lower speaker, whatever is low. Yes? Okay. Now, what will be next? Next will be this device. This is the mixer, and it will mix. It will mix what? It will mix input signal, and it will mix LO. And if I'm telling that first producing 10 megahertz, that means that machine will provide this intermediate frequency 10 megahertz plus 3 minus 3. It just translates your 500 kilohertz crown into this image, keeping the same distances. Whatever was 500 plus minus 3, now it's at 10 megahertz plus minus 3. In order to do this, you have to tune this local oscillator to this. And you need 10.5 minus 500, it will give you that 10. Are you following this? Do you understand this? Right? Anyone who is out of this? Of course, anyone who is late already missing this explanation. I'm not going to repeat it. Okay? In order to produce here a new carrier, 10 megahertz, surrounded by this plus 3 minus 3, we need to have local oscillator tuned to this. And we need to have 10.5 minus 500, and you will get 10 megahertz. And what we'll have here at point 4? We'll have new intermediate frequency, which 10 megahertz plus and minus 3. That's it. And of course that one, F low, how to be tuned to this. This minus this will give us that new carrier. We're just translating from one carrier to another carrier. Intelligence always stays the same. Your crown moved from 500K to the 10 megahertz with the same. Now, what is next? 5, amplifier. No change, just amplitude. That means whatever you got here will be at output 5. Just amplify it. And maybe filter it, because we need to make sure only this will pass. Any question? It's so simple. And we did it in a class. Now, next, at 6. Now it's a new translator. But now it translates in a different error. Now it's 445. In order to get here 445, we need certain frequency to subtract that what we have. Here we have 10.5. Here we must have 445. What we will do? Create that difference. Yeah? Now we need new LO. That LO will be 10445. 10445 minus 10000 will give us what we need. New I. Just always think about this as a frequency translation. They just move carrier into the new region. Whatever is new carrier, you have to have that LO to generate this carrier. LO minus old carrier will give you new carrier. LO minus old carrier will give you the new carrier, right? Now, and this is detector. Detector will remove your integrity. Obviously, output of this will be your integrity. 3K. What will be inputted to the detector? New crown. Now it moved. First, at the antenna it was 500K. We moved it to the 10 megahertz. Now we moved it back to the 455. And all this 3 goes in the detector, and the detector outputs your intelligence. 3 kilohertz. What's this? Audio amplifier. What it will do? Nothing. Just amplify. That means it will have the same audio. Now, I suggest for you, just at home, in case of studying, change your input carrier, change all this new, you may say this, make it 1 megahertz or 5 megahertz, make it, I don't know, 1 megahertz, change your new carriers, the numbers. Always remember, at the antenna, you have 3 things, and they present at higher frequency. It's a carrier plus smaller. 3 kilohertz is a far at the transmitter who took that in Chile and modulated your AM signal and created new package. And the package is 3 harmonics. And what that machine does, it just translates carriers in the new values, tuning LOs. You need to have a certain frequency to create new carrier. Whatever the old one, new one. And you have that number, this minus this will give you this. This minus this will give you this. You can do the 10 mixers and they all will do the same. You just translate carrier for the sake of, if I have very nice amplifier, very linear, beautiful, but it cannot work on high frequency gigahertz, I will just translate my carrier into its region of the kilohertz, give it to the amplifier, amplify, and then if I need to again to do something, I can move it again back to the higher frequency. So. Okay. I think this question is clear. Yes.
Can you talk about the last one again?
Last?
Yeah.
Which one last?
Calculation and the image.
Oh, that one?
Yes.
Yes. Image. Whatever images it says, what is sitting at antenna. Yeah? Whatever carrier we have at antenna, yeah? And at the antenna we have 500K. Yeah? And we used first mixer tuned to the 10 megahertz, specifically to the very high frequency, because if you look at the formula of images, it's RF plus minus 2IF. And if you put here 10 megahertz, that will be 20.5 megahertz. Out of all my filters, out of my region, if it's standard broadcasting region for the IM, that image will be way outside. We will never pick up this at antenna. But if this will be my standard 455 kilohertz, then whatever is my carrier plus 2 multiplied by 455 will be somewhere already here. Image may be sitting here, and we will pick up that station and this station. That's about images. That's why we have at the first mixer very high carrier translation. It moves image far away from existing real stations, right? And same problem you encounter in frequency modulation. Same thing. When you receive FM, it just FM travels in high carrier. FM can be at 10 megahertz, 9 megahertz, and it will have the same image. That means first mixture will be maybe 20 megahertz or something to move image far away from standard FM region, because now it has higher frequency carriers, FM. Yes?
It's negative 19.5K, but can it also be negative 19 or negative 20.5 and then?
It's just part of math. You have only positive. You just take absolute value, plus minus. Basically, it's only that will be But again, if it's your carrier is here, then minus maybe will be sitting in this channel range. Whatever positive, whatever is negative, it's result of the math. Just take absolute value. Now I'm coming back to another heavy thing, which is that one.
Oh.
Yeah. Only probably 5 or 6 students manage it. That will be really heavy, and that's good. You'll be ready for the test. Now, talking about the test and quizzes. After studying this quiz and going through double-sided observation, I think you'll be well prepared for the test. What do you think if I will lower the mark for your quizzes and increase mark for the test?
Yes.
Yeah.
Whatever, right now, your total quiz costs you 10. That means each one is 5 and 5.
Make each one one.
Yeah, I will make it 2 quizzes for the 5, 2.5, 2.5. And your test from 10 will go to 15. Whatever belongs to the quiz, I will give to the test. What do you think?
Yeah.
Right?
Yeah.
I'll give you solutions. On the back pages will be some.
Yeah.
But okay, take care of this. Do you agree with that new algorithm?
Yes.
Whatever process belonging to the quiz, I will transfer to the test.
No, I like
Because
35.
for some reason, most of you failed the first quiz, and that first quiz mostly was about resonators, filters, both plots,
The first I get
which
72.
is
If I plus that,
I wish I had more time to
and you
do
can pass
reasoning about this
those
kind of
options.
fight, but I don't have that time. The time only for the AM. Now, let's talk about this.
不要拍了，把这给你
Yes.
录下来了，你自己。
Before, okay, total cost for the quizzes was in my half is 10. You did 2, that means each is now 5 and 5. It's a huge, and because you did it not so good, it will impact your overall mark. I will lower this mark. I will give for the 2 quizzes only 5 for my portion. That means each is 2.5%. Right? The remaining 5 I will include into the test. Whatever you will get for the test, instead of 10, you will get 15. Right? Because still we have to do is put money in your bank account, your marks. Okay.
那天就说现在还有效果。
For some reason, let's say 35 student struggling with reading the divisions of that displays, both time domain and frequency domain. I don't know why. You did so many times in the lab, and I was explaining how to read display of these instruments. And this is frequency domain instrument. It has a vertical, it has a horizontal. Horizontal is a frequency, and vertical is the decibels. And please, your reference, not in the middle, not in the bottom, not at the noise line. Some of you managed to use reference at the noise line. I don't know why. It's always on the top. If it says reference 0 decibel M, this is 0 decibel. If it says reference 10 decibel M, this is 10 decibel M. Now we need to know the steps, and steps is scale. So that specific reference starts from the 0 and goes down by 10 decibels. Minus 10, minus 20, minus 30, and we don't worry about this part. We only worry about the peaks, power of these peaks. Okay, now frequency. Again, I realized from this quiz, maybe now things improved because you did more labs and we had some explanation again. But for the start and stop, it's easy. You start with whatever start, 670. Stop, 690. For some reason, some of you used start, and they said 670, and stop 690. No, no, no. We're talking about settings for the display. Whatever is inside, it's a different story. But for the display, that's the start, that's the stop. Again, some of the students, for some reason, divided the span by the 9. I don't know why. Because it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 divisions. Why divide by 9? I don't know. And all this can be, of course, wrong. For the specific, if it's 670, 690, that's the span. Length of this line is 20. How many divisions? 10. That means 20 by 10, 2k each step. Now, having all this info, we can recover frequency and the powers. Okay, frequency. Center now will be 680. Some of the students properly found center 680, said, okay, this is frequency 680. No, it's not 680, it's not in the center. It's slightly on the side. You have to calculate how many. Okay, that's the carrier, 6, 7, 9. And that's it. Once you found the carrier, just relax. You don't need to find its period, because I'm not asking to draw a period for the carrier. Remember I was saying, don't worry with the carrier. Just draw the envelope, intelligence. What is intelligence here? Intelligence sits in this side bands. You can use either this or this, they're both equal. And it's same distance. Okay, if it's 670, again I'm counting how many? 1, 2, 4. 670 plus 4. 674k. You follow me, right?
Mm.
Okay, what is the actual intelligence? Because it's plus minus from the carrier, I will take my 679 minus 674, and that will give me my intelligence. 5 kilohertz is intelligence. But that 5 kilohertz intelligence carried on the waves, airways, by the frequency of 500k, 500 plus 5, and with minus. I mean 679, sorry. Do you understand this? Now if you have something like this in your test number 2, can you recover the frequency? Of course. But again, it might be not straightforward, start and stop. It may be center frequency and the span. And you know how to do this when you have center frequency and the span. Yes? That's how you do this. Whatever is the center, and it's, I don't know, 7k, and span is 100k. What's the meaning of it? That
650.
means center will be 700k.
650.
And span is 100k. That means plus 50 plus 50, because this length is 100k. What will be the start now? 700 minus 50. 650. What will be the stop?
750.
700 plus 50, right? 750. From center and span, you can find start and stop. Do you understand how to do this?
Yes.
Anybody not okay here? Good. Okay, powers. Now I have to put the reference, 0, and step down. Okay, this somewhere here. And it's increasing down. That means whatever is that small size of it increases from 10. And for me it looks like 70. So kind of 7 and this is 3. But anyone who put here 18, 16, 17 was okay. But whoever used that portion and said it's a 23 or something else, were wrong. Because you're decreasing down 0, 10, and you have to travel a little bit more and little bit more. It's kind of 7th part of this one. That's why for me it's a 10 plus 7, 17 decibel, and it's minus decibel. Okay, what is the power of the sidebands? Any of it. Okay, 1, 2, 3, exact number. You don't need to look for this small sided. And it will be minus 30. Sideband is minus 30. That's how you do this. Always go from top, and it will increase in terms of the minus. Less power. And the scaling and the reference may be different for your test. I can put here maybe -5, and scaling will be 1. That means -5, -6, -7, -8, right? Okay, we found powers. From the powers, we can find voltages from the formula for the power. And we need to know modulation index. Yeah? And modulation index was given in the formula. But anyway, you need to know delta. And delta is just difference between this. In decibels. Just subtract this from this. That's your delta. Because in the formula it's a delta dB with minus. This minus this, it's still minus. Minus 30, minus. And when you put this in the formula of this, you will get modulation index. We already have too much information. We know the carrier, we know the frequencies of this intelligence, we know the powers, and we know modulation index. By the way, if you want to use a ratio of the powers, here, don't use decibels, you have to use powers. For me, it's much easier. You just need to find delta, put delta here, and find the result. For this baby, you need to find actual powers. If you put actual powers, and I put here or, that's why it's too many things, because I was giving to you all versions how to do things. Yeah? If you want to use that formula in watts, here have to be. Now you need to recalculate all your decibels into the watts. And if you put proper decibels, you will get proper powers. It's 1 microwatt and it's 1990 microwatt. Don't remember, you're multiplying that expression, but why milliwatt? Because that's the general formula. Decibel M is 10 log whatever is the power divided by 1 milliwatt, not microwatt, not watt. Milliwatt. That's why letter M here. I wish I was teaching you this era. Anyway, we got powers, we got modulation index, and now it's a piece of cake. From the powers, we need to find voltages and use these voltages to draw the envelope of it. Part of the envelope already known. We know that it's 5 kilohertz. That
Oh, I see.
yeah, that envelope frequency follows 5 kilohertz. We need to look now on divisions, find out cost of each scale. For this we have 50 microsecond per division, 50 microsecond per division. My 5 kilohertz gives period of 200 microsecond. That means period will be 1, 2, 3, 4. 4 of divisions. In terms of the frequency, I got it. Now we need to find maximum and minimums. First, from the power of the carrier, yes, I found its peak. Yeah? That's the power, that's the peak. Yeah? 45 millivolt. 45 millivolts, but I need peak to peak. Multiply by 2, 90. And my carrier, unmodulated, because it's the power of the carrier that will be changed by the intelligence.
What frequency to 5K?
Yeah? And I will start with unmodulated. This is unmodulated carrier. Now intelligence switch on, and it will start modulating. Minimum, maximum, maximum. From the definition of modulation index, which is a ratio of your peaks You know already peak of the carrier. You know your modulation. You found it. Here, this way or this way. I suggest to this way because it's simpler. Now, ratio rearrange. That's your peak of your 20 millivolts. Okay, you look at the settings. It's a 20 millivolts per division. That means it will go up by 20. It will go down by 20 millivolts. It will go to the maximum by 20. It will go up by 20. That's my end goal. Any questions? Step by step, it's always simple. But when you put things together, instead of just piece of metal, piece of plastic, piece of glass, you have a car. When you put this together. Each step is simple, but create your AM transmitter. Questions?
So can you repeat how to get the maximum, the BP?
Do you understand how you get peak unmodulated carrier?
Yeah.
Yes, that's then modulated. Once you got this, now it's ready to be modulated. From the modulation index, which you found previously, 0.5, you can find peak of the intelligence. And just you need to add that peak up, down, up, down, down, up. Right? You did everything separately in a class. You never did this together. And once I give you, okay, now create the machine, you were lost. Because I'm sure if you cut this in separate questions, find the power, next question. Find the modulation index, now find the do this. But once I put this together, you were lost. Come on, you big boys and girls. Do you understand how to do this? Good. Now we can do something minor. First, it's all from your notes. Just you repeat your notes. Same thing. When it's over-modulated, what happens? First, it distorts your envelope. Instead of nice, crisp envelope, now it will go to the bottom, it will go to the top, and that portion will be screwed up. Distortion changes the shape. K at the end. It's moved first here, they move here, that was used for the text. Down? There's nothing down. You will do this. You will do this.
Up, up.
More?
Yes.
More? Yeah.
The high level modulator. I need to go there.
Yes. I'm not going to put any solution on board. You're all welcome to participate, ask questions, put the notes, learn. Anything posted is a source of some ambiguity and something for the next generation. Don't confuse next generation. Because I have some students memorizing answers for the test from year 2008 and putting all this without thinking in the year 2013. And when I asked him from where, he was looking at me and said, I don't know, sir. I just remember, sir.
That's good.
Different numbers, different words.
It's the only
If you
one I
don't
did
understand,
good on.
ask
I
me
lost
questions, I'll
2%.
give you the answers, but nothing gonna be posted. Nothing gonna be posted.
Yo, we got a video of it. We're gonna be doing it.
One question.
Yeah.
You have some, by the way, you have some practice.
Yeah, we got
Some
YouTube.
assignment, practice. Yes. Lab quizzes.
So lab test is Tuesday.
Okay, I can do the same trick. Whatever is your lab quiz, I can transfer to the lab test if you want. Now, lab test. Lab test. I'm gonna send you email and announcement on the blackboard. Section B and section A will be divided into two groups. Lab test will only one period. Software or hardware. What is the hardware? Generate AM signal, function generator, scope, decimal lines. What is the software? Use circuit maker to generate AM using blocks.
About what? AI? About that lab test? About AI?
About frequency modulation. About
okay.
what? What is studying here? AM. Generate AM.
Are we going to use a program to
Are we going to use what?
use a circuit maker or
I just 1 minute ago I said circuit maker, use circuit maker to generate AM. Ask me again.
What's
Use circuit maker to generate AM.
做了，
Sorry?
有问题。
And we're going to use hardware to generate AM.
那你那个图没有啊？得了，得了，得了，得了，得了。
and this is based off of what?
I need up, up, sir, up.
Okay, he's not doing it. Just video this.
I need one, just the last one because I don't. The video is loose.
Dude, just this is the right answer.